Hello there, students and friends. This video is about a problem on mechanical power. So stick around, watch and learn. The given problem reads, a 1,200 kilogram vehicle accelerates from rest to a speed of 27 meters per second in 5.0 seconds. Question is, find the power the engine exerts on the vehicle. Two students gave two different solutions. Student A uses the formula for power, which is P equals force times speed. She first calculated for the acceleration using the formula in kinematics. Final speed minus initial speed divided by the time elapsed, or 27 meters per second minus 0 meter per second all over 5.0 second. And he got the value for the acceleration, which is equal to 5.4 meters per second squared. He then proceeded to calculate for the net force using Newton's second law, F equals ma. That is, the mass of the car, which is 1,200 kilogram, multiplied by the acceleration, 5.4 meters per second squared, and got the value for the F net, which is 6,480 newtons. And finally, he calculated for the power using the formula P is equal to F times V, or 6,480 newtons times the speed of 27 meters per second, and his answer is P equals 174,960 watts. For student B, his solution is based on the formula P is equal to delta KE divided by the time T. This is a formula based on the work energy theorem. All right. So, getting the value of the change in the kinetic energy, you have delta K equals 1 half times the mass, which is 1,200 kilogram, multiplied with the square of the speed, that is 27 meter per second squared. And the computed value for the change in kinetic energy is 4,037, or rather 437,400 joules. And solving for the power, delta KE divided by the time T, and substituting, all right, we get 437,400 joules divided by 5.0 second, and the computed power is equal to P of 87,480 watts. All right, so the two answers are not the same. You will notice that student A's answer is twice the amount of the power calculated by student B. Who do you think between the two students gave the correct solution? All right, so using student A's solution, the power that we calculated is P equals 174,960 watts. while the answer of student B using his solution, P is equal to 87,480 watts. Now, we ask which between the two students has the correct solution and answer. Alright, so take note that student A used the formula power is equal to F multiplied by the speed V. Alright, this kind of solution, that means the solution given by student A is the power that is instantaneous. Right? In other words, the power exerted by the engine of the car at time equals 5 seconds. So this is called instantaneous power because it refers to the power when the car has a final speed of 27 meters per second. Whereas student B's answer is what we call the average power from the initial time of 0 to a final time of 5 seconds. In other words, what is the average power exerted by the engine on the car as soon as it starts to accelerate, alright, from rest to a final speed of 27 meters per second in an elapsed time of 5.0 seconds. So who between them gave the correct solution and the correct answer? Well, it depends on what specific kind of power is being referred to in the question. In short, the problem doesn't specify if we are looking for the instantaneous power or if you're looking for the average power. At this point, we say that the two students gave, okay, two different answers from two different solutions depending on how they interpret the question. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.